Hello everyone, welcome to our presentations, and I am grateful to the MSM 2020 conference committee member for giving us the opportunity to present our research works titled as Lifetime Improvements of Smart Sensor Maintenance Protocol in Prospect of IoT-based Rampal Power Plant. I am MD Shadul Haq, working as a senior lecturer, Department of Tripoli, Feni University, Bangladesh. Here's the research outline. The research outline consists of the following points. The first one, we have discussed briefly about our research background, and then we also introduce why and what is necessary TC protocol. After that, we have bring the problem statement, which is related to the present monitoring system, and then objectives of our research works. And then research methodology, and we also analyze the research result, then conclude our research work, and also recommended the future works, and finally the reference. Here's the research background. Research background consists of 4 points. We have sketched out. First one is the introduction about the WSN or smart wireless sensor networks, and then why it's important, why wireless sensor or smart wireless sensor networks coming, and then what is the application area of the wireless sensor networks. And we briefly discussed the 2 related work we have found through our literature search in the literature research works. Okay, first one, wireless sensor network is the combined application of sensor node for measuring physical phenomena like temperature, humidity, and others. Actually, recently, smart wireless sensor networks is becoming a lot of attention due to the smart handling, reconfigurable, and other lots of things for sharing the data and also information from one node to the another nodes. What is the importance of WSN networks? The importance of the WSN networks is vital. In everywhere we found the network. In everywhere, including the smart monitoring network, there is also include the sensor, and then it's also able to monitor in harsh environment, and where the always accessible of the human on other things is not possible. Here is the application outlines. We have outlined the following application: power plant monitoring system, agriculture monitoring, habitat monitoring, indoor living monitoring, climate monitoring, forest monitoring. We have sorted out these 2 literature review works we found through the literature search. First one is the Arthur Lee et al. Described the development of smart wireless sensor networks for real-time solution, but they don't discuss about the how they will control the node energy or the connections. The second one, we found the most similar works is also developed the real-time monitoring system, but this one is the address the issue of workload, but don't work with the maintenance protocols. What and why TEC protocols? TC means topology control protocol. Topology control protocol is composed of the topology construction and topology maintenance. Basically, it's work on node parameter and the connection of the nodes. The first one is apply the topology construction, which connect the topology connections. This is the topology of the networks, and then second one is the apply of the topology maintenance. Now, which apply to consume the network node energy and preserve some nodes for future use, and in such a ways the lifetime of the monitoring network is also increased. That's why topology control, there are finally we can tell for topology maintenance, which for lifetime saving the most vital is to play the vital rules for extending the lifetime of the monitoring networks. From the literature review, we have found the following research problem. First one is the energy monitoring is needed to decrease the energy of the energy of the power plant or other business system, and then a smart monitoring or a smart track of the energy is required, and also the scarcity of the maintenance protocol in power plant monitoring system, and then limited life cycle is found due to the all node apply in a once. The objectives of this research works is categorized in three points. For the first one is the design and development and stable monitoring network in the era of IoT. The second one is the combined application of the TC and TM protocol for monitoring system for lifetime engaging. And then third one is the performance analyze using the integrated approach TC and TM protocol. The left side is the whole research methodology we have followed in our research works. The right side figure shows the simulation for a simulation scenario, simulation flowchart for our simulation works. Here's the total overall scenario of our architecture of the node in the power plant monitoring system, how we will apply and which manner on how we organize the node or how we place the node in the in our application area. Here we have consider 60 meter and 60 meter, 600 meter and 600 meter. Sorry, this one is 600 meter and 600 meter. For our simulation case, this can be increases, but if you increase, then we need a lots of sensor. We consider for a simulation case 100 number of sensor node, and then we organize them uniform distance from each other, and we apply the node uniformly. This is the simulation scenario. This table describes the simulation consideration of our proposed model. And this is a visualization of our topology scenario network, which is considered as a dense topology network in applying monitoring of power plant and system. And this is the analytical formation of our dense topology monitoring system. And this is the this equation describe the describe the node energy of his node, and this is the mapping value of his node energy, which is considered as electrical energy and amplifier energy. This one is can be changed using in the software compiler if you want to change, but this one is a standard value. That's why we use this one. Most of the researchers use this value for optimum of the network architecture. Okay, this is the proposed model of our simulation scenario. We have considered 100 number of nodes, and the communication nodes of is communication node radius is 100 meter, and then the sensing of his node is 20 meter. And this one I already mentioned. This one is the area of the monitoring in which we deploy our networks. This is a 60 meter, 600 meter, 600 meter centralized position of the nodes, which is known as the base station or sync node. Is the 300 meter and 300 meter. We have applied the Gaussian distribution model, and the energy of the Gaussian distribution is 1000 millijoule. For topology construction protocol, we use A3 and EECDS construction protocol. And for maintenance, we also use HGTT-ROT, DGET-REC, DGTT-REC, HGTT-REC-ROT. We have elaboration those in our article. If and sensor and data protocol, we just simple model we use, and for routing also we use simple forwarding. We have measured the performance metrics, actually 4 types of performance metrics: number of nodes, reachable nodes, and another is the communication coverage area and sensor coverage area. This is the simulation result of our case study. We have continue 4 course study. The first one is the number of active node. This is the number of active node. This is the percentage value. And here is the topology construction protocol. Here is the topology maintenance protocol. This value I determine the how the node we are used. If we use or if you get the 100% value, that means all the node is active. The major goal of the topology maintenance protocol is to use the minimum number of active node and then provide the maximum outputs. That means the lower the value of the number of active node is provide the good for lifetime assumptions. This one is the number of reachable nodes from the sinks. This one requires also most access of the node, but this is a trade-off between two things. We want to sleep minimum number of node and want to gather the maximum data from the employee area by employed area. That's why here is also the minimum number of nodes is preferable. But one thing we have to mention that the minimum number of nodes cannot cover the most of the area. This is a trade-off between those two things. This is the communication coverage area results. Actually, this one is we always accept is more, because the more the communication coverage area and the more connectivity is acquired, and also we can gather the lots of data for our monitoring cases. Here is the sensing coverage area. This one we always accept is larger sensing coverage area, because we the more or the larger sensing coverage area means we can cover the larger distance for our monitoring cases. That's why this one always we accept the larger sensing area. From our work, we have concluded those things. We have proposed the dense topology maintenance protocol for monitoring power plant system. Basically, we have chosen the RAM power plant for our experimental data or simulation data. We found that the combined approach of A3 coverage and DG-ET-RAC provides the better result in case of number of active node, reachable node, and communication coverage area. On the other hand, another combination mode A3 coverage and ACE, GTT, RAC, ROT provide the better result for sensing coverage area. We believe that this will help to for developing the real-time scenario to improve the lifetime of the monitoring system for power plant. This is the future works we have noted based on our literature survey. We have planned to work in agriculture plant monitoring system using IoT networks, and also apply deep learning for power grid fault monitoring, and another one for image was damage identification of nuclear power plant. This is our for future work suggestions. Here is the reference we have used through our article, or we have worked through the citations. Lots of thanks, everyone.